Hey, let's have a look. Let's have a look at this. Okay, so what we want to do is we want to start over here with these ones in the corner. Bloop. These ones. Because these are really easy to do when you find them. So basically when you have a 1 here in the corner, it means that either this space or this space has to be a mine. So then this one here, because this or this has to be a mine, its condition is already met, which means that this space here is always going to be safe. So if you have 2 1s against a wall or a gap, the third space is always going to be safe. In this case, this makes it so this 2 is only touching 2, which confirms this space and this space as mines already. And then you can, free up all the rest of these spaces as well around here, because obviously this would be a 2, and these would all be 1s, etc. Anyway, so this would be 2, 1, 1. One. I don't know why I immediately swapped to a worse pen. Anyway. Yeah, so all of these would be free up. You wouldn't be able to get this space here. You would be able to get these spaces, and because this is blank, you would free up all of this. And you would be left with like, oh, the pen gets so big. 1 here, 1, would be 2, 1, 2, 2, 1. The space is a 2 as well. That's all the spaces that you would uncover from doing that. Anyway, back at it. There is not enough information, I don't think. We know that there has to be a mine here or here, because both of these 2s have 1 there that it has to be. But because of this 2 up here also here has to be a mine. Oh, actually we have this 1, so we know that because of this 1 here, we know this 1 has to be a mine, which means that one clears up, and then this 1 has to be a mine, and then all this clears up. The 3 is done. Oh, I'm gonna regret that. Was it 12? It was 12. I have another turnip pen. Yes. Smaller. Why does it have? Why did I make it have a outline? Watercolor edge, no. Okay, there we go. What did I just do? I just did this 3. Okay. This one would also be a 3. And this one would also be a 3. Which would guarantee this one because we already covered that was a 2. And then that one's satisfied. This is satisfied here. This one we already know is nothing because this 2 is already touching 2. This would have been a 2. Would have been a 1. This is so blurry. I'm going back to this pen. 1. So that's a 2. Is that satisfied? That means this one can't be 1. It would be another 2 here. Means that this one has to be a 2. I actually just want to step back a second. Is this 3 here? We can work out that this one is a mine before doing any of this. Because there has to be 2 mines within these 3, right? And there has to be, well, we know this is, so I'll remove this one as well. One mine within these 2 spaces. Well, no. We don't know that there has to be one. We do know there has to be one mine, but because there has to be 2 mines here, here, or here, but these 2 can't both be mines because this 2 is already touching a mine. So only one could be here. And because there's only 3 spaces and these 2 can only have 1 in them, that means that this third one, this orange one over here, has to be a mine. And we can work that out before we did any of the other stuff. So that's useful to know. I went back. So that one's satisfied now. And of course, because, like I just said, this one is already touching those 2. This can no longer be a mine, which makes these 2 confirmed. Now 2, this is only touching 2. This one is also confirmed. This is touching 2, which makes this one safe. And now this 2 is only touching 2, which confirms that. So 3. Yeah, that's what we can do. I mean, obviously, there's 1. This is confirmed. So we know that we're gonna have all of these. You know, we can work. This one will be clear. This one will be clear. This would be a 1. This would be a 3. Oops. this would still be clear. There's nothing in here. Ain't nothing in here. I think this would be 1, 1, 1, 1, 1. Is how that would shake out. Now this 3 down here, we've already satisfied with this one over here, so we know that this one not gonna be anything. And it's going to be a 4. Yeah. Anyway, so now this 3 here is only touching 3 squares. This one is also confirmed to be a mine. Which means that this one is safe. And this one would be a 2, and this 4 is now satisfied. 1, 2, 3, 4. This one is also safe. And this would be a 1. Now this 2 is only touching 2, so we know this one has to be a mine. Which means that all of these 1s that are already touching 1 would become completed. These are touching 2. Would have been a 2. Would have been a 1. There's nothing, so this would have shown up this. And that's not right. And this. And this. And this would have all showed up. Which then, this one here being the only one left that this can touch. Confirmed as a 1 there. Which means this one opens up because we can guarantee that there's nothing there because of this 1. This would also be a 1. Means that we can also get rid of this square. Nope. And this square. One wouldn't have anything, and this one would be a 1. Which is guaranteed on this one. And yeah, I am. And then this one also. I'm still doing what I was doing before. And that would be that. That would be that solved. Those were the only 4 touching, yeah. And all of that stemmed basically from being able to do this corner here with the 2 1s. There are a couple other ways that you could solve some of those, obviously, like the 3 guaranteeing here. But otherwise, yeah. That's how that would have played out. Mostly at the further from the point where I finished explaining things previously. All the rest of Minesweeper is just a process of elimination, so it's like if these 2 have to have a mine, and that means that this one can't have a mine, for example. So it's similar here. We're going to assume, for the sake of this, that this is a wall or a gap on either side. I don't know if it actually was or not, but I know you've already solved this, but I'm gonna show you how to do it really simply. This 2 is touching 2 on this far side, so we know that these 2 both have to be a mine. This one, therefore, because this one in the middle is already touching 2, we know that this can no longer be a 2. And then this 2 here is only touching 2 now. And so on and so forth. This has to be 1, this one can't be anything, and this one can't be anything, so then you know, I'll just do it rather than and this one can't be anything either. And then there has to be a mine here or here, which means that this one is satisfied by that and this one can't be one. Similarly, if you're here, it could be mine. This one couldn't be one either. So that leaves that first square to be a mine and this square to be a mine. And that's how you would solve that. That way you can also do it the other way around, in which from the side here or here has to be a mine. So this one cannot be because this one is already satisfied by those 2. And then it starts over from like this one or this one has to be a mine. So this one can't be. This one or this one has to be a mine. But in this case, because it's a 2, and we know one of these has to only contain 1 mine and we need 2 to touch, we can know therefore that this one would have to be a mine. And from there, you know, it's the same. 2. This one has to be mine. Means this one can't be, this one has to be mine. Which means this one can't be, which means this one has to be mine. Exactly the same, but slightly different, and hopefully that'll show you how to do it if you had like a 1-2 situation. And that's it. That's how you solve those ones. I hope that helps. The end. Gotta find my OBS. Bye bye.